Today we are covering parent functions and transformations. Update your table of contents and then start your title page. Go ahead and hit pause. Okay, the stuff that is highlighted in green is the things that you need to copy down. Don't worry about the things that are in yellow there. Also, you're going to want to take a moment and just kind of read through this. So go ahead and hit pause and then I'll scroll down. Alright, there's the rest of it. Make sure that you've read through these and that you understand all of this. Alright, and then I would like you to have some graph paper to carefully plot these points. So make sure that the identity function has 1, 1, 2, 2, 3, 3, and so on. The quadratic function, first one is over 1, up 1, and then it's at 2, 4. So be very precise in how you are plotting these points. Go ahead and hit pause. And then this whole top table up here, I would like you to copy all of that down. Today we're going to be talking about the translations from the parent functions. So this squared tells us that this one's going to be a quadratic. The absolute value bars tell us that this is going to be a V-shaped graph, an absolute value equation. The rules are the same for it. A affects the steepness of the graph. H affects if it shifts left or right. Notice if it's plus, it's shifting to the left. If it's minus, it's shifting to the right. That's kind of backwards of what we would expect it to be. And then the K values at the end, the constant, is up or down. And again, that is if it's positive, it goes up. If it's negative, it goes down. That's kind of like what we expect it to be. The H is the one that trips us up because that's opposite of what we think it should be. So go ahead and hit pause. And then just take a minute and read through these. Okay, then let's get started on the examples. So example 1, just make a sketch of this graph. It does not have to be perfect. We're just identifying the type of a function that this is. Since this has this V shape to it, this is considered an absolute value function. Example 1b. Alright, this one we're looking at, it's a U-shaped graph. A U-shaped graph means that it's going to have an x squared part of it, and it's also a quadratic. This is the technical name for this U-shaped graph is a parabola. Alright, example 2. Now we're going to go on graphing these. So the first thing we need to do is take a look at our equation and decide which type of graph is it. Is it going to be linear? Is it going to be quadratic? Or is it going to be absolute value? And the way you decide is because of the squared. A squared is going to be a quadratic. Okay, so quadratics start like that, with 0, 0, 1, 1, 2, 4, and so on. 3 would be at 9, 4 would be at 16. Now we look at this and see how is this transformed. It is plus 1. So remember, the 1 is in that H spot, and that's the one that is opposite of what we think it should be. So plus 1 actually takes this whole quadratic and moves it to the left one. And so that is the shape of our graph. That is the final answer for that one. So go ahead and draw this on some graph paper if you have it. Okay, the next one. We start by looking at the equation, and we notice that there's absolute value bars. So the absolute value is this V-shaped graph. Alright, so here's the parent function, and now we have to decide what happens to the parent function. What a negative does is it reflects the parent function. So we're going to have to flip this graph upside down. So that is our graph reflected over the x-axis. It's still the same shape of the parent function. It hasn't shifted around. It's just been reflected. So go ahead and sketch that graph. Alright, example 4 then. Now we look at this graph. And again, it is an absolute value equation, so it's going to be that V shape. So let's put the parent function in place. This time, it's not a negative graph, so it's not being flipped over. it does have a 1/2 in front of it, so that affects the steepness. Now the way that the steepness works is the bigger the number, the steeper the slope. So since this is a smaller number, it's going to make the slope wider. And this is very similar to a linear function, so we're going to go up 1 over 2 to make this graph. So if you go up 1 over 1, it would result in the red graph. Alright, go ahead and sketch that one into your notebooks. Okay, now we're going to do a graph that has a lot of different things in it. So we first have to decide which shape is this graph going to be. The squared indicates to us that it's going to be the quadratic graph. So let's put the parent function in place and kind of manipulate it from there. So let's start with our horizontal movement. The 5 inside the parentheses is the horizontal movement, and again, that's the one that's opposite of what we expect. So since it says -5, we need to move it right 5. So that's our horizontal movement. We've taken care of this 5. Now we need to take care of this 12.5, and that is our vertical movement. So we need to move this up 12.5. Oops, undo that. There's 12.5 approximately. Now we have a -1/2. The negative is going to flip it over, and the 1/2 is going to make it a less steep slope. So we're going to need to flip this over and then widen the graph. So I have now flipped the graph and I have widened it a bit. Now the widening or making it steeper for a quadratic, I'm not going to be too particular on it. You do not need to make a table and have the exact values in there. That is how you would do it. You would make a table, just pick some x and y values and then figure out the width of it. All that I'm going to be concerned about is the fact that you know that it is wider than the parent function or that it is steeper than the parent function. So a 1/2 is going to make it wider. For example, a 7 there would make it very steep, and so it would be inside here, making a quadratic graph, a parabola. So you don't need to be concerned about how wide you make it, just that it is wider than the parent function. Alright, that's the end of the lesson, kind of a short one for today. So go ahead and write your summaries and your questions, and let me know if you have any questions when you get to class.